Good day, ladies and gentlemen. This is Sarel van Grennen, aka Mr. VG, and welcome back to video 3 in our series of geometry revision. In this specific series, in this specific video, we are going to look at quadrilaterals. Now, this is video 3 of the theory videos, okay? Kind of the last one, And although I say geometry revision, some of these concepts are going to be very, very new for grade 9s, depending on your teacher. So when we look at this, we have in our first video went over angles and lines. If you haven't seen this video, please go back and look. Go back and check this before you move on. We are actually going to use this a lot, angles and lines. Our second video was all about angles and triangles. Now, when we look at angles and triangles, the previous video, I forgot to mention that there's a specific reason that is needed for this theorem. If angle x is equal to y, then AB is equal to AC. Why is that? Because sides are opposite equal angles. But for this video, I'm specifically going to have a look at quadrilaterals. Now, quadrilaterals are awesome shapes. Awesome because they've got a lot of amazing properties. But we are going to build on those properties and use them kind of mixed together with the previous triangles and parallel lines. So please, please, please make sure you've watched the previous videos. When I look at quadrilaterals, a quadrilateral is literally a four-sided shape that's closed and has straight edges. But I'm going to start by looking at the number of parallel lines that there are in my specific shape. That's how I love to classify them. The first one is, what if there are no parallel lines? Isn't there a specific quadrilateral that has no parallel lines? Yes, there is. And that one specifically comes before the ones where we look at one pair of parallel lines, and even before the ones where we look at two pairs of parallel sides. Now, the one that has no parallel lines is a kite. The basic definition of a kite says it's got two pairs of adjacent equal sides. Now, what properties does a kite have? Well, first of all, the opposite angles are equal, but only the ones that are squashed between the non-equal sides. What if I now look at the one pair of parallel lines? Well, that is specifically a trapezium. Now, a trapezium doesn't have many properties, although I can use F, U, and N because I've got one pair of parallel lines. Next up, I've got my two pairs of parallel sides. The first one that falls into this category is a parallelogram, or a palm, as some people affectionately know them. If I broke up my name in a weird way, please forgive me. But parallelograms have got a number of properties. Look at those. Opposite sides are equal. Opposite angles are also equal. Very important. But under parallelograms, I have two special shapes: rectangles and rhombi. Now, why do I put them under parallelograms? Well, it's because they've got all the properties of parallelograms, but a rectangle just has an extra 90 degrees, while a rhombus actually has all the sides that are equal. You see, they are special parallelograms. Last and definitely not least is the most complicated one, which is a square. And this falls under both rectangles and rhombi. I mustn't forget that it's also under rhombi, but also it's actually a kite because it has two pairs of parallel adjacent. Oh my goodness, what nonsense am I talking? It's got two pairs of equal sides that are adjacent to one another. Now this is grade 8 work, not to be funny. But in grade 9 what makes it different is now we're going to introduce diagonals. And we are going to look at the properties when we introduce diagonals. So let's start by, again, going to my quads and splitting them up. If I look at the no parallel lines and I look at my kite, the first thing is look at all of those properties that now happen when I introduce a kite. First of all, the diagonal is cut into two. So there, let me not forget that little thing there. My one diagonal is cut in half. The diagonals are perpendicular to one another, but also that long diagonal bisects the angle perfectly, so it also cuts it in half. Next up, I look at my one pair of parallel lines. Well, there's nothing that really happens when we introduce diagonals in trapeziums. It really doesn't do much. So I'm going to move on to two pairs of parallel sides, those quads. First of all, when I look at a parallelogram, if I draw my diagonal, first of all, the diagonals bisect each other. That's the only additional property that parallelograms have. Remember, it also has all the properties on the previous slide, but specifically in this slide, when looking at what is added on extra, it's just that the diagonals bisect one another. If I now look at those two, let me go back a bit. If I look at rectangles, the same thing happens, but now the diagonals are equal in length. So in other words, all four of those lines are now equal. Very crucial. Nothing too serious, but my specialty is rhombi. Oh, they love to ask rhombi. Because not only are the diagonals bisected, but they are bisected at a 90 degree. Now, I love to ask this for my grade 10s and 11s because they forget about that property of a rhombus. Now, let's look at what happens to the angles. Well, those two are the same, as well as those two angles are the same. Why? Because of the sides being equal in length. Same with those two, same with those two. So your diagonals bisect the angles. So there's a lot of extra properties that come with rhombi. Last is our square, which has a lot of extra properties that now comes into play when I introduce quads. So first of all those four little diagonal parts are equal. So the diagonals bisect each other at a 90 degree, but also the angles are bisected at 45 degrees. Very, very easy, but very, very important. Now we are going to use these properties in the next videos. So tune in and make sure that you know these theorems, grade 9s. You need to know them. This is Salo van Grinnen, aka Mr. VG. Have a gorgeous and beautiful rest of your day. Please sign in for our next video, so we're going to start practicing these properties. Keep well. Cheers.